Good afternoon, everyone, and welcome to episode 2 of the M Word. My name is Robin, or Rob, whatever you prefer, and I'm the technical director of Man and Machine in the UK. A special hello this afternoon to an extra couple of viewers that I've got. My little darlings are at home watching, so enjoy half term, and thanks for watching. So, episode 2. Hoping for no demo ghosts today, so hopefully it all goes nice and smoothly inside the applications. But we're going to look at 2 things specifically today. One for manufacturing inside of Fusion 360, and the other for construction inside of Autodesk, Revit and Enscape. So what I thought we'd do first of all is look at some new functionality that we've got inside of the Fusion 360 Generative Design extension, which looks specifically at fluid path analysis. And it uses the Generative Design tools to optimize your design for fluid flow around or through a product. So we'll take a little look at that first of all, which is really cool and really quite neat inside Fusion. And although it sits inside of Fusion, remember that Inventor nowadays can link directly to Fusion nice and easily on a single button. So that'll be quite interesting to see that as well. And then once we're done, we'll just jump quickly inside of Revit and we'll launch up Enscape and we'll show you how we can both link Revit views to views directly inside of Enscape using different visual styles. It's quite a quick tip and it allows you to get some quite nice results while you're viewing your model in VR or presenting, that's not a word at all, presenting to your clients on a power wall. First and foremost, I'm just going to do my usual little push for followers. So please like, subscribe, comment, hit the little notification bell so that you can see when we're live and when we put new content up. We've got a load of different content on the channel, from how-tos, tips and tricks, from AutoCAD, Plant 3D, InfraWorks, Inventor, Fusion, Revit, you name it. And there's videos on there spanning from a couple of minutes up to hours in length to really give you the best tips and tricks you can find for computer-aided design in Autodesk software. There's also a plethora of BIM-related content and digital construction-related content on ISO 19650 and other valid standards as well that's really worth a watch and should help you out if you're on a journey towards BIM compliance. So give us a like, give us a subscribe, and don't forget to throw a comment at it as well. If there's something that you want to see or a topic that you would like us to discuss during these sessions that are now weekly, then please leave us a comment and we'll do our best to follow those up with you. But without further ado, we're going to jump straight in. So let's just shrink myself into the corner. Magic, there we go. And we will share my screen and we'll jump straight in. And I think we'll start today inside of Fusion. So we'll start with the manufacturing path. So I'm running the latest version of Fusion 360 and I have the Generative Design extension which I'm subscribed to inside of Fusion, which basically means I've got access to the Generative Design track in here. Now, you can come on and grab a trial of this. You can access this using credits. You can buy access for a day, for example, or a short period of time. So just jump on to this little extension cord icon up here and you can go and access the Generative Design to have a play around with it should you want to. And if you do go about things that way and don't quite know where to get started, remember that if you hit the data panel on the left-hand side there, you've got a whole load of different official samples that the Autodesk tech team have put together. And you've got some Generative Design samples on there that show you how to do some of the standard Generative Design functionality, as well as the fluid path as well. We're not going to do that today. We're just going to literally model up an example from scratch to try and explain what we're doing and why, and hopefully that will try and bring the functionality to life, but also the ease of use as well. I'm keeping my fingers crossed that we're not going to get any demo ghosts show up today and jump out into the software, but we should be absolutely fine. So what we're going to do is just a simple sweep and put some obstruction geometry in there. And just imagine that we want to get some optimized flow of a fluid, such as water, through that design. So let's go ahead and create a sketch. Let's just draw on my front plane here and go ahead and draw out a diameter circle. I don't know, let's say for the purpose of this, we want to do a 15mm pipe. Maybe we're just going to do a copper elbow or something and throw some design information through there. Maybe we'll make it a little bit bigger for the purpose of this. Let's go 50 millimeters. Let's offset that outside around about 5. And let's create another sketch from the top down this time. And we'll sketch a path. So let's press P on the keyboard to project the geometry of the center point of my circle. Let's look at this from the top down. Use my line tool L on the keyboard, and we're going to come 100 millimeters in this direction. We're then going to grab our line, click, hold, and gesture an arc. Nice little tip there. If you are in the line tool, you don't need to escape out to start the arc tool. Just click and hold a point, and you're able to gesture an arc with your mouse, and that'll be tangential to the first line. So we'll gesture an arc, roughly about 45 mil in radius there, and then we're going to pull off perpendicular at a right angle. That's 90 degrees for those younger viewers amongst us, and we're going to go another 100 mil or so to the right hand side. Once we've got that, let's just control this dimension here, just because we can. 50 mil is absolutely fine, and let's go ahead and finish the sketch. We're now going to pull a create and use a sweep to grab the external profile here and pull it along this path. So a nice simple shape, nothing too difficult, and we're going to do that as a new body. Now before we go too much further, what I'm also going to do is add another extrusion, but just show those that original sketch just here, which is sketch 1. There we go. Let's do another extrusion of this face here in this direction, 2 millimeters, as a new body. You will see why shortly. Maybe let's go a little bit bigger than that, 5 mil. So we've got a new body to work with there. You'll understand why in a second. Let's do the same on the other end. So let's go and grab this end here, P for project the geometry, grab the center circle, hit OK, and then again extrude E on your keyboard, pull that out, and again we'll just go 5 mil. Make sure you do that as a new body, like so. So that what we end up with inside of Fusion is 3 bodies. We've got what is going to be our design or our product, and then we've basically got 2 simplified inlets and outlets. So one of these is going to represent an inlet where water is going to come into our design, and the other one is going to represent an outlet where we have a zero pressure of water flowing out of the design. Once we have that, what we now need to do, if we just turn off those bodies, is we need to have a representation of the starting shape of the fluid, okay? So we need to actually create a volumetric model of the inside of this shape. So what I'm going to do is a couple of things. I'm going to go to my Surface tab. I'm going to say Create. I'm going to create an offset surface and click the inside of this face and the inside of this face. I'm going to offset them by 0. In other words, creating an exact replica of the inside surface. I'm then going to turn body 1 off. I don't need it anymore. I'm then going to say that I would like to patch this, press OK, and I'd like to patch this, press OK. This is now a complete representation of the inside of that elbow that I'd modelled. So let's just stitch it together. This patch, this surface, and this patch here. Hit OK. And what we'll end up with is a representation of our fluid as it stands. I'm just going to rename these bodies just with a slow double click on those bodies just to rename them. Let's call this body 2 the inlet here. Let's call body 3 the outlet. Now we don't actually need the design anymore at this stage. We can turn it off because we're starting with a base shape. And then the generative design tools are going to iterate and iterate through a number of different process flows to try and get this to a point where it's at best case scenario for pressure loss, for example. Just to give it something to think about, I'm going to add, a bit unrealistic, but I'm going to add a couple of shapes in here for it to navigate around. So let's go back to solid. Let's go and create a sketch. I'm just going to go and pick the center plane in the middle there. And again, we're just going to create a couple of very, very basic shapes. I'm just going to do some simple rectangles. Again, it really doesn't matter for the purpose of this. It's going to be quite rough and ready. But I want to show you how Fusion is able to use obstructive geometry to calculate a flow. So I'm simply going to have 2 enclosed surfaces. I'm going to extrude both of those closed loops in both directions, so they're symmetrical. And I'm going to extrude them up as, again, a new body. You'll notice I'm doing everything as a new body because I need to be able to select bodies later on for the simulation. Let's press OK. It doesn't matter that we've got self-intersection everywhere. It really doesn't affect what we have here. Let's just rename these bodies now and say intersect 1 and intersect 2. Now we've got those, I'm just going to hit a quick save and just call this simple fluid path. And I'm just going to save this into my CFD project here and hit save. Once we've got that, we're going to use our workspace selector and choose Generative Design. It's our first design in here, so it's going to say, well, do you want to do a structural component or a fluid? I would like to do fluid path, please, and I hit Create Study. And much like all of the other we used that last week, like all of the other Fusion interface, it's left to right. It's very natural. It's just like reading a book or writing a sentence. So we're going to start on our left-hand side and we're going to work our way to the right. So we've got a study, which is great, and we've got a model that's pretty ready to go, in honesty. I just need to tell it to turn the bits off that we don't need. So I could go into Edit Model and do that, and I could turn any of these bodies on or off. So I'm just going to turn the design off. Or I can just open up the model components here and control them through that interface. Once I've got that, I choose how each of those components are going to be handled by the design space. And I've basically got three different, or five if you want to, four. We've got preservation geometry, obstacles, a starting shape, and then an obstacle. An offset, sorry. So let's preserve this body here, which is my inlet, and this body here, which is my outlet, and hit OK. Let's go ahead and choose obstacle geometry. These two here are going to be obstacles for this design. And then I can choose my starting shape, which is this one in the middle. Again, that's a volumetric model that is the inside of this elbow or tap, if you like. Once we've got that, we need to give it some conditions. So how is the fluid driven through this design? So I can say define this shape here as an inlet. I can have a flow rate or a velocity or a pressure. I'm just going to say that I want to have a flow rate in here. Okay, we can change the units. Let's have, maybe we want to have litres per hour, and let's just say 100 litres per hour and press OK. We can then say that we want another design condition, which is on the other end. We can in there say that we want to have a pressure, and I'm just going to put a pressure of 0, which just means there isn't anything pulling the water. It's just a point where the water can escape, for example. Hit OK. You notice instantly when I've done that, my little clipboard here is just on a pre-check to say that you've done everything that you need in order to progress. I could change materials if I want to. I'm using water. I'm absolutely fine with that. And I'm going to go ahead and hit Generate. This is going to sit there in the background and start processing on the cloud. It will take a few seconds initially because what it needs to do is package up that model as a model file and throw that up onto the Autodesk servers. Once that's up there, it will open that file on the servers and it will start processing those geometric shapes into a generative design model. It just gives me a prompt to say, okay, I'm now up and running. I can close this window, and in the normal circumstance, you would just go and have a cup of tea while it does this first one, for example, or you might go and start some different work whilst this is processing on the cloud. It's not using my machine, so I can go and use my machine for other bits and pieces. It's quite a simple design, so it should relatively quickly give me my first example. I'm going to give it a few seconds while I talk a bit more to pop up with one to go and have a look at, and you'll start seeing it process and process and process in the background. If it's not there within 30 seconds or so, I'll just go and open one that I did earlier to save waiting for the study. But what this is doing is it's giving me an environment where I can see what points it gets to. One thing that I didn't show you in the design is we have criteria. So I could have gone in and said that I want to get a 25% reduction in pressure loss, for example. And what this is doing is not just showing me how the fluid is routing through a design, it's also going to show me a more logical or a more optimized shape that design could or should be from a starting perspective. So if I let this go for long enough and process and process and process in the background, it's going to give me a much smaller shape to give me an optimized flow around those two obstacles. We'll just give this a couple of seconds while it hopefully finishes that first one. I would like to show you it on the same model if I can, but again, if it doesn't, I'll open one up in the background, which I might just do anyway, to show you one that is pre-done. So let's go ahead and open one because it's still processing. It should be finished by the time we open up the next one, but I'd like to show you one with some outputs anyway, so I don't necessarily just keep talking over the same things over and over again. So this is just one of the official examples. It's a very similar process. You have your existing conditions with, in this case, they've got some obstacle geometry at the start to say I can't go outside of that area, for example. They've got their initial fluid shape. They have a simple mixing cage in here and this obstacle geometry as well. And if we go and have a look at this particular one and go to explore, we will see that this has been through several different instances of design. I'm just going to open up this first one here just to show you the kind of outputs while we're waiting for ours. And what this shows me is that on that design, if I go and say, show me my traces here, or flow lines, it shows me fluid coming in, going around those two obstacles. Remember, there's an obstacle here, and there's a cage in the middle that it goes through. Okay, so it's showing me where I've got high velocity, drops in velocity around and over that shape. Let's just jump back to mine. It's got one outcome. It's queued it for download, so that should be done any second. And what this will do is it will just sit there and give me those results, and it will iterate them over and over and over again until it finds a design or a mesh that is best suited. Again, in this example, that yellow shape that we started with, just here, let's just turn the obstacle and preserve geometry off. This yellow shape is what we're saying, well, that's my mass of fluid. And what the generative design is telling me is this shape that's left here, this is your optimum fluid shape, if you like. That's where the fluid needs to go to get through this with as minimal pressure drop as possible, or flow drop. That will then allow you to take this, create a design from this outcome, which gives me a solid that I can then work with, and then you can start designing around that to get the outside shape of this design set in stone. Let's just jump back to my one here. Still processing, so it's nearly there. Should be done any second. And this will just iterate over and over and over and over again until it thinks that it's got to the best point. So the first one that you see in our simulation that we've just run just now this afternoon, the first one will be relatively simple following the shape that we modeled. But then the second, the third, the fourth, the fifth one will start to limit the actual size of the fluid down so that it doesn't have any areas of low flow, any stagnant water buildup and stuff like that. So it's a really useful tool if you're looking at airflow through a component. So fans, for example, through an electrical piece of equipment. If you're looking at fluid flow through a pipe or through a design or a tap or a facet. Really useful tools. I was really hoping that at that point I could open this up. It's still thinking. It looks like it's not a million miles away, but we might just have to come back to it shortly to save me saying the same story over and over again. But the key really is how you start it. So if you've already got a design, you create a volumetric model of the inside. Just cap either ends with the patch tool and just create those boundary conditions, and then use something like Stitch. If you were going from Inventor, you could use Sculpt to create a sculpt of the outside design and the two patches. That gives you your starting fluid. You then have a shape at the start and a shape at the end for your inlet and your outlet, and then you can start the process as we go through. It looks like it's going to take a little bit too long to actually wait for that, which is a bit annoying. I'd hope that excuse me, I'd hope that had been done by now. I'll give it a couple of seconds more. If it's not there, we'll jump onto Revit, and then we'll come back onto this once it's done in the background. It's probably that I'm streaming. I've lost a bar on the Wi-Fi, so we'll give it a few seconds. We'll come back and show you the result at the end. We'll probably have 2 or 3 iterations once that's done. So that's the first thing I wanted to show you. That's now there. It's preview, so it's still a design preview. It's not fully released functionality. But that means that if you have the generative design tools inside of Fusion, this will just keep growing and growing and growing. So head over onto the design discussion forums, the Fusion discussion forums, use it, give feedback, and see the tool set build and progress as we progress through the coming weeks and months ahead. The second thing I wanted to show you was inside of Revit. Obviously Revit is construction, so it's complete role reversal from having my manufacturing hat on. So I'll just take that off and put my construction hat on. There we go. And we're now talking about Revit, which is there for the designing of a digital building. I'm just going to purely focus on this from an aesthetical or an architectural standpoint today. And literally I'm going to do that with the standard Revit sample project. It's okay, it doesn't look the best in the world, it's been around a long time now, maybe needs a little bit of an overhaul. But for the purpose of this, it's a familiar model that you would all seen and probably opened at one point or another. But what I want to do is just explain that when I want to visualize this using something like Enscape, for those of you that haven't used or seen Enscape before, it's a third-party plugin for Revit. It's not free, unfortunately, it is charged, but it gives you very, very easy access to super high quality rendering to make your model look really nice, but without having to go through 3ds Max, Arnold, V-Ray, or any of those other high-end rendering tools. I can literally just hit a button inside of Revit and it does the job for me. I'm not going to do a full rundown of Enscape as a product today. Check back at a later episode where we will do that. But I want to focus on leveraging information that I already have in Revit, in Enscape, and then some Enscape functionality on top to really try and make that unique. So inside of this design, if I just have a look at my project browser, I've got a number of different 3D views. I've got my approach, which looks like this. I have my from yard, it's American, looks like this. Kitchen, living room, so on and so forth. And each one of these is a saved view inside of Autodesk Revit, which has a saved visual style, a saved standard. Clearly this is going to turn on ray tracing or something. Yep, there we go. So these all look a certain way in Revit, which is nice. But wouldn't it be nice if we could have that difference in look and feel when reusing these views inside of Enscape? Because any view that we have here inside of Revit, if I just go to my Enscape tab up here, we can access those views directly inside of Enscape. So just to make this a bit quicker, I'm just going to close down those 3 views just so I've got my basic view open. And I'm going to say, do you know what? Let's use that kitchen view that you've just seen. Let's go to the kitchen view and let's press start. Now this then works its magic. It will sit there with a progress bar. This, as you know, if you're an Enscape user, is completely customizable, so we can change the appearance of these loading screens and stuff like that. Let's minimize this. It's on my other display. Let's just make it a bit smaller, just so it runs nice and snappy for the purpose of this as we're streaming. And this will load up Enscape. So in the background, this is doing some clever things. It's taking the model, it's putting it into the Enscape engine, and it starts to make it look nicer. So inside of here, yes, it's a live environment, you know that, but it's stored that exact view from Revit, but it's using it with Enscape's visualization tools. Now, you will all know that inside of Enscape, we can also then start looking at our different views. So the views that we have, I've lost my view button now, where are we? Views, there we go. The views that we have inside of Revit, we can directly then go to. So if I go to my approach view, if I select that, it will go to the approach view. It's not changing the style or the look and feel of the model. What we have is Enscape's very nice looking, very attractive renderer with its 3D rendered animated grass, which looks lovely when you get down close to it. We've got our nice RCP elements, and generally something that looks really nice. It's Enscape doing what Enscape does best. But wouldn't it be nice whereby if I was going from a very aesthetical view where I wanted things to look as good as possible with a really nice rendered image, to maybe a section view that I wasn't too fussed about the visual quality from a render perspective, but wanted something that looked more like a technical design, technical illustration. And we can absolutely do that inside of Enscape leveraging the same functionality that you have inside of Revit, visual styles essentially. So let's go full screen in Enscape now, because you've seen that these are linked Revit views, which is great. Let's go back to our living room view over here. And then what we're going to do is go up to the visual settings, top right, and we've got a load of customizations. Okay, you'll notice I'm currently running on a custom preset. All right, so what I'm going to do first of all is put this up to Ultra, pushing my luck a little bit here. Hopefully the demo ghost doesn't come out, just to make this look as crisp as it can in the background. Okay, and what I can do with this, you see this little arrow on the left here, that's going to show me a different menu. So with that preset, I can right click and rename and say Rob's Renders. Caps locks on, there we go. Rob's Renders, or Rendered Views. And in there, I can go through and make everything look the way that I want. So I want 2-point architectural perspective. I want to play maybe with the ultra visual quality, so that it's using RTX and ray tracing. I want to correct my contrast. I want to play around with any effects that I have to make this look as nice as it can be. But then I want to create a second preset. I want to call this Technical Illustrations. And with that technical illustrations, that's a mouthful, technical illustrations view, I'm going to go in and say that I want to have a style which is white mode. I want to put my outlines up. You'll notice in the background instantly that's changed. So I want white. I don't want any of my my textures on there. I want to have outlines on there, just to make the edges appear more prominent, so like a technical illustration would. Again, you can type in if you don't want to use the slider. You can also revert to a previous setting if you've made a mistake. So let's go to about 60% there on those lines. We can say that we want to work with an orthographic viewpoint rather than perspective. We can play around with exposure, image quality and atmospherics all in the same way. I'm not going to. I've just got these two presets. They can be exported. So I can save those presets out onto a network drive or throw them up onto Autodesk Docs or another common data environment whereby I can share these with the wider team. But for now, I have these presets. Okay? So I can go to Rob's rendered view. It thinks about life for a couple of seconds because that was on Ultra, but it shows me that rendered view. Not quite sure what's going on there, but it shows me the rendered view nonetheless. If I go to my technical illustrations, again, it will think about it for a couple of seconds while it changes the settings, and there we have the technical illustration. With those set up, I can make direct links to my views on the left-hand side. So if we just close the visual settings panel here, if I go to my living room view and hit this button just here, we can link the living room as a view to Rob's rendered views. And obviously you can have several on here if you wanted to. We can also make this a favorite view before hitting save. I can then go to my section perspective, edit that view, make this one a favorite and link it to my technical illustration before hitting save. From there, if I close, have a look around, we can see that we are not within that, that sectional view. But if I go to view management, section perspective, hit the button, let it think about life, it will go and load that section view. If I just sit here and let it think about it, it's not too keen on the railings that I've got there because I'm cutting through them. That's more my own issue. I should have gone fully beyond them or the other side of them. But if you leave it for long enough, you'll notice it kicks in. What that is the anti-aliasing. So if I just move this around a little bit and then let go, look here with the crispness of this shadow. It looks awful. It looks horrendous. It looks like something from a Super Nintendo. If I left that long enough, it would iterate and iterate and iterate and iterate until it became very smooth and anti-aliased. So it takes lots of noise and it will get rid of it. The same is happening with these lines. It's going to sit there, not really figure out how it should display them, and then it will think, your camera is staying still, and you'll notice that they, over time, gradually become solid lines. No two ways about it. I should have had the section in a different view, but never mind. Not the demo ghost, at least, just my own problem. If we go back to a different view, so let's go to my from yard view, not using anything because I didn't link it to anything. Go to my living room, it links it to the visual style, so it takes that little bit longer just to change the view, but then instantly you're getting your rendered result. So the ability to link Revit views with Enscape views and then link those in turn to a visual style. And those visual styles can use anything from that visual settings dialog box. So they can have different HDRIs, they can have different qualities, they can have different look and feel. So you could have one that's making use of the light view, for example, to give you an idea on lux levels, one that's using technical illustration look and feel, one that's using a real rendered output quality. So fantastic product. I can't rate this product enough. I love it. It's great. I think we'll do a different session in an episode in the weeks to come, which goes through it in a bit more detail. But nonetheless, really useful functionality. Create all your views in Revit, use those to navigate through inside of Enscape. So just to finish off, with a bit of luck, because we are at the half-hour point now, we now have a couple of designs on our Simple Fluid Path V2. So what we're going to do is open up Study 1, give it a double click. You can see that it's still thinking about life. It's not quite finished, but I've got enough to be able to have a look through it. So what we can do here is see that already, if we go and have a look at our flow, remember this was 50 mil all the way along, and it was extruding or swept, sorry, around the corner. We can already see that it's decided that based on the shape that it's trying to navigate around, this is the best flow. If I'd have put in a larger obstacle, so it was 50 for a longer period of time before getting skinnier, it would have thought about life a lot more. This is already on iteration 10 out of the best possible 11. If I drop this back to iteration 1, which is the first simulation it's run, we can see 50 mil all the way along. And from there you can see stagnant areas, waste areas of design where the water doesn't actually, or the flow in this case, doesn't actually get to. This would fill up the water, but you'd have water here that doesn't actually move anywhere. What the system's doing is it iterates and iterates, and it's saying, well, this area here isn't great because it's just hitting this wall. The same up there. So the generative design functionality is literally minimizing the loss of your fluid. And as you go through, we can see that for each one of these, it's just going to get narrower and narrower and narrower until it's at a point where it's literally like almost like a racetrack. Comes on here, does a little chicane, and through the other side. Which reminds me, 1 month the Formula 1 season starts. Should be good this year. So yeah, really nice tools, very easy and accessible. They sit inside of Fusion. You don't have to export it out to a different tool set. This doesn't replace Autodesk CFD simulation tools because it doesn't have yet quite the number of options that does for looking at temperature, mixing and outside conditions and stuff like that. But for simple flow through a design to either optimize a shape or minimize pressure loss and stuff like that, it works really well. And you can see that as we approach the final iterations of this, it's basically saying, well, what you need to do, unless you need that element of mixing there, is just design it to not have those shapes there, and you have a general better mix. But nonetheless, nice tool, easy to use. So let's unshare the screen. And without eating cake, make me much bigger. There we go. Would prefer to eat cake, but that would be very bad for me. And that brings us to the end of episode 2. No demo ghosts. Yes. Don't speak too soon. Probably drop the Wi-Fi and freeze. But major look. Yeah. So yeah, thank you very much for watching. Thank you very much for taking half hour or so out of your time. I hope that's been useful. Again, fire us some comments, give us some feedback. We really want to hear what you want to see. We want you to have a look at the videos that we've got online, take a look at the different content that we've got out there, subscribe, set up notifications, and let us know what you want to see, and we can make these sessions as interactive as possible, rather than me just picking what I want to talk about and talking about it. So next week we will be on Thursday at 3 o'clock, might be half 3, half 3, go with 3 o'clock. 3 o'clock until 3:30 on next Thursday. We'll be back again for another session. In the meantime, enjoy your week, hope it's not too busy. Pancake Day next Tuesday. enjoy. I know that I will. And take care. See you soon. Thanks for watching. Goodbye.